Hey everyone, it's Doc. Great to be here. Excited to be here. Miss you guys. Been loving having seen you guys on my Zoom office hours in the chat room. It's been great. Great. Can't wait till we're back together in class again soon. So until then, I'm going to do another video today on valence electrons. Yes, they're your favorite thing. It's super difficult. It's hard to learn this, and that's why Khan Academy focuses so much on it because, well, hey, they think it's one of the most important things to learn. So that's why my middle school science, my chemistry, and my biology are still working on valence electrons. Then they'll branch off into different sections, just like my earth science has branched off a little bit. Okay, so what I want to do is today talk about CO2. But before that, I do that because it's a little complicated because it deals with triple bonds. I want to take a step back and talk about what I briefly touched on last time, which was water, which was H2O. And if you remember, it looked something like this. Okay. Hydrogen has one dot because it's in the first row. Oxygen had 6 dots. 1, 2, 3, 4, 5, 6, because it's in the 6th column over. So hydrogen, first column, 1. Beryllium, magnesium, calcium, second column, they would have had 2 dots. Boron is in the third column, it would have had 3 dots. Carbon, which we're going to be talking about today, has 4 dots. Oxygen is in the 6th column, therefore 6, and so forth, and so on and so forth. Okay, so here was the H2O, the elements. Here's each one. Here's each element. And they're going to combine and share to make everybody happy because hydrogen would like to have a full valence, a full outer shell, and it can hold 2. So it wants this one, and then, hey, it'll share this one. Oxygen wants 8. Well, it has 6, but hey, I'll share with this one, and I'll share with this one too. So that'll give me 8. So that's how that works as far as sharing electrons. And when we draw it to, in dot formation again, they're sharing these 2 electrons right there, okay? So hydrogen, 1 dot, 2 dots now, so it's happy. Hydrogen over here, 1 dot, 2 dot, it's happy. And oxygen wants 8, it has 1, 2, 3, 4, 5, 6, 7, 8, so it's happy. Now, whenever we see bonds like this, where we have 2 right in between letters, we just draw a line, and that represents a pair of electrons. There's 2 there, right? 2. So 1 line would equal 2 dots. And you draw that like this. There's my H2O right there. Okay? I have 2 H's, 1 O, H2O. And that's how I would draw the Lewis dot formation for that molecule, H2O. We're going to do the same thing for carbon dioxide. What's carbon dioxide? Well, it just happens to be one of the most important gases to sustain life on our planet because we breathe in oxygen and breathe out CO2. And what breathes in CO2? Plants. Plants breathe in CO2 and they respire and breathe out O2, which then we breathe in. So without that relationship, we wouldn't be here. So what I want to do is I want to talk about carbon dioxide, the gas. It's also in soda, has carbon dioxide bubbles in it. Okay, it's prevalent throughout the entire planet. So here we go. Carbon is in the 4th column, so it has 4 dots. 1, 2, 3, 4. 4 dots, which represents 4 electrons. Notice how I drew it on the square. I kind of like to do that just so I know that I'm going to have pairs. Okay. Next up, I want to combine that with oxygen. Oxygen is going to have 6 dots. 1, 2, 3, 4, 5, 6, because it's in the 6th column over. So it has 6 dots. Again, I drew it on the square. So it looks like this area right here, he'd like to share one there if he could, or here. But over here he's full because he's got these 2 dots next to each other. You can only have 2 dots on a line of the square. Okay? So what I want to make is CO2. That's what we breathed out, CO2. So I have an oxygen, I have carbon, and another oxygen. So I have two O's, two oxygens, so CO2. That's how you write, if you're writing in a sentence, you'd write CO2. And this is the elements that would be in CO2. And again, I'm gonna go slow, go back. Carbon, how many dots are on the outside of carbon? It's in the fourth row. Therefore, 4 dots, and I have 1, 2, 3, 4 dots, okay? I have my oxygens over here. I haven't drawn the dots yet on them. It's in the 6th row, so how many dots is each oxygen then going to have? Well, let's take a look. It should have 6, right? That's what we're hoping. And here's my paper up here. 1, 2, 3, 4, 5, 6. Same with this oxygen over here. 1, 2, 3, 4, 5, 6. And you can kind of tell, it looks like, hey, these guys could probably share. These guys could probably share. Maybe this one could share with this one. Maybe this one could share over here with this one. You know, somehow they can combine to share because, remember, they want to be happy. They want to have 8. Well, oxygen has 6, so it has spots for 2 more. Carbon has 4, so it has spots for 4 more. Okay? So there happens to be 1, 2, 3, 4 lonely oxygen electrons, so maybe we can make that happen. Let's see. When I kind of draw a diagram of how maybe they would like to share, it would look something like this. Okay? So this oxygen electron would like maybe to go over here. This oxygen electron maybe would like to go over here. This carbon one maybe would like to go over here in the empty space, and this one maybe over here. And if you look at that, it almost looks like I have 2 lines going that way. And oddly enough, that is a double bond, and that's how we draw it when we get to the final explanation of what carbon dioxide would look like in a Lewis dot formation as a molecule. Okay? So again, what I'm going to do is I'm just going to draw all those dots together now, share. And I've got them circled in red. So these guys are sharing. These guys are sharing right here. And remember what I said about sharing electrons. If there's a pair, you can draw a line there. Well, there's 1 pair. There's 2 pair. There's 3 pair. There's 4 pairs. So I could have 4 lines. 1, 2, 3, 4. Hooking those together. But let's make sure everybody's happy. We've got 1, 2, 3, 4, 5, 6, 7, 8 oxygen molecules happy. Carbon 1, 2, 3, 4, 5, 6, 7, 8 happy. This oxygen 1, 2, 3, 4, 5, 6, 7, 8. So by sharing, they get to count these electrons all the way over here and all the way over here to carbon. These all the way to carbon, and these get to be counted in oxygen as well. That's what the sharing is all about. Okay? And if I draw the lines, look something like this. Remember, I've got 8 over here, so I'm happy. These are 1, 2, 3, 4, because each line equals 2 electrons. Each line, 2 electrons. 1, 2, 3, 4 right here. 1, 2, 3, 4 right here, just like I had drawn on the previous page. So happy, happy, happy. Everybody is happy. That's what it's all about, keeping those electrons in the shells where they can be happy. All right? And finally, the way you would draw that, remember I said you would write it CO2, and you would draw it like this. You wouldn't have red ones, you'd have black ones right here. Okay? And again, this is difficult. This is hard to understand. We're talking about double bonds. Okay? Double covalent bonds. But what I want you to understand is, if we go through it slowly, you can draw almost any molecule with the elements once you learn this procedure. Okay? The only other bond left to learn is a triple bond, and we'll learn that on my next video. Okay? So, very good to be here. You guys breathe out, breathe in, breathe out that good old carbon dioxide to help those plants. Breathe in the good oxygen. And I will see you on my next video. Okay? Doc out.